Good day, students. How are you doing? This is me again, Sir Navarro, and welcome to our YouTube tutorial video. In this video, we're going to discuss the continuation of the variation, which is all about combined variation this time. So, what is a combined variation? So, combined variation, it's just an upgraded version, dated, upgraded version of inverse variation. This time it involves or yeah uh, another variable, not just x and y or not just two variables, right? So for the definition, let x, y, and z denote three quantities. Y varies jointly as x and inversely as z. If there is some positive constant k such that y is equal to kx over z. Number k there is again the constant of variation. So if you notice from the word itself, combined variation, and then in the statement of variation, there involves jointly, inversely, or sometimes directly and inversely. So meaning it's a combination of the three previous variation that we've discussed already. So there are times that it can be more than four variables, no? So since we're talking about joint, and then there will be a denominator on the right side of the equation since we're talking about inverse. All right, now let's continue with the definition. Let's now proceed to the examples immediately. So first, find an equation of combined variation. Let's try to put it here. Maybe somewhere here. Okay, so where y varies directly as x and inversely as z. One set of values is y equal to 4 when x is 6 and z is 3. Find y when x is 15 and z is 10. Now, if you notice, there's the statement, the word directly, no? So just like what I've said earlier, the joint and jointly or directly terms can just be used interchangeably. All right, meaning they're just the same. And then there should be an inverse to the number, or somewhat like there are other terms for inversely, all right, but later. So one set of this first set of values is given now. So first thing you have to do is always find the constant of variation, all right? So express the statement, no? This is quite basic naman. So y varies directly as x and inversely as z. So yung translation is y equal to kx over z. And then let's now solve for the k so that we can find the equation. So just substitute the first set of data. 4 for y, 6 for x, 3 for z. And then cross multiply. 4 times 3 equal to 6k, which gives 12 equal to 6k. And then so that we can find k, we need to divide both sides by 6, and then which gives us an answer of k is equal to 2. We're not done yet. We still have to make the equation, which gives us the equation of y equal to 2x over z. Replace the k lang. And then, we now find y using the second set of data. So, to find y, just use the equation and then substitute x and z here. So, x is 15 and z is 10. So, 2 times 15, that's 30, and then divide by 10, that will be y equal to 3. Alright? Questions so far? Good. So let's proceed to the next example. So example number 2, if z varies directly as x and inversely as y, and z is 9 when x is 6 and y is 2. Find x when z is equal to 2 and y is equal to 12. So again, we translate the variation statement to in an equation, no? So which is z equal to kx over y. Just follow the sequence of how the terms or the variables are written in the problem. So in this case, z is equal to kx over y. Now to find k, we need to substitute lang the z, x, and y. So on the first set of given data. So our x is 6 and 9 is for z, y is 2. So there, and then you just have to cross multiply. This is 9 times 2, which is 18. and then divide both sides by 6, which gives us a k of, what's the k? The k will be 3, correct, 3. So which gives us the equation of, therefore the equation will be y equal to 3x over z. Actually, this is not y. There's an error here. So there, it's z is equal to 3x over y. Okay. So now we solve for what is being asked, which is find x when z is 2 and y is 12. So to find x, again, we're just going to use this equation and then just replace z and y with their corresponding values, which is 2 and 12 respectively. Sorry, this is y. This is y, so 2 for z and 12 for y. Then just cross multiply, that gives us 2 times 12, which is 24, and then divide both sides by 3. Therefore, x is 8. Is that okay? Okay. No questions so far? Well, let's proceed to the next example, number 3. If y varies directly as x and inversely as z, and y is 6 when x is 8 and z is 4, find z when x is equal to 12 and y is equal to 4. So let's translate this statement to variation. So this is y equal to kx over z, and then the second step is to find the constant. Just replace the y, x, and z with their corresponding first set of values. So, y is 6 and x is 4, x is 8, z is 4. So cross multiply, this is just 24, and then divide both sides by 3, that gives us, divide both sides by 8, that gives us with a k of 3. This will be cancelled. 24 divided by 8 is 3. Let's proceed. So this is y equal to 3x over z, our equation. So we're going to find z using this equation. So just replace y is 4, x is 12. So if y is 4, x is 12, so 3, just interchange this one. So this will be z here, and then the denominator becomes 4. 3 times 12 is 36. Divided by 4, that is just 9. Follow, ra? Do you follow? 4 times z is just being replaced. Okay? Interchange their position. Okay? So, let's proceed to the next example, number 4. If y varies directly as x and inversely as z, and y is 3 halves when x is 3, z is equal to 12. Find y when x is 2 and z is 24. So in this case, same process, no? The equation will be y equal to kx over z. Take note that there are fractions also when we deal with problems soon. But when you deal with this kind of fractions, the way you solve it is similar to solving integers, right? Similar approach, no? Similar approach. Not similar manner, but you apply a similar approach in manipulating the equation. So now let's find k by replacing this first set of values. Y for 3 halves, x is 3, and z is 12. So if y is 3 halves, that is there, and then x is 3, z is 12. So we cross multiply. 3 halves times 12, that is just 3 times 12, 36. Divided by 2 is 18. Again, 3 times 12 is 36. Divided by 2 is 18, equal to 3k. And then divide both sides by 3. Don't mind this one. This is actually k equal to 6, which gives us the equation of the variation y equal to 6x over z. Now to find y, we just replace x and z. So replace x with 2 and z with 24. So there, 6 times 2 over 24. 6 times 2 is 12, divided by 24, that is just equal to 1/2. Since you cannot divide 12 by 24, you can just reduce it to its lowest form, simplest form, Alright, let's proceed. For the fifth example, no, it involves a lot of fractions na. But anyways, yeah, just like what I've said earlier, you just have to deal with it in a positive manner. So again, we translate the equation. So m is equal to kn. We translate the variation statement to m equal to kn over p. And then just replace the values m and p. M is 5, n is 3/4, p is 1/5. So m is 5, n is 3/4, and p is 1/5. So cross multiply. 1/5 times 5 equal to 3/4 k. So this is just equal to 1. Am I right? Alright, so this is just equal to 1, right? So 1 is equal to 3/4 equal to k. Diba, when we divide this one by both sides, or when we cross multiply, this is 4 na, equal to 3k. And then we divide both sides by 3, that is just equal to 4/3. No? K is equal to 4/3. Or you can just simply divide both sides by 3/4 here. You will end up 4/3. K is equal to 4/3. Okay? Sige. Since our K is 4/3, we can say that our equation is m equal to 4/3 over n, 4/3 n all over p. Okay? So we're going to use this equation in this case, and then just replace m and n to find p. So our m is 2 and n is 9. So if your m is 2 and then your p is missing, you just have to interchange these two. So this will be now, by the way, 4/3 times 9, this is just 4 times 9, 36. Divide by 3 is 12. Am I right? Again, 4 times 9 is 36. And then divide by 3, that is just 12. So p is equal to 12 over 2 since we interchange p and 2. So therefore, p is equal to 6. Questions so far? Wala? Okay, so if you don't have questions, we can now proceed to the next class. Anyway, the next video will be uploaded. So, if you have questions, you can just type or comment in the comment section. Thank you and God bless. Thank you for watching.